Okay, for this problem, let's work back the other direction. So let's say we have a 26-inch diameter bicycle tire, and we know that it's rotating 10 times per second. Okay, what we want to ask is how fast is the bicycle traveling? That's what we want to find out. So let's go ahead and draw out a picture of what we got going on. We know that we've got the tire. We know the radius of it, again, is 13. Okay, so the question is in one rotation, how far does the bike travel? Or how far does, well, I guess the bike or the tire. Okay, so same difference. So we did this in the last problem. Let's do it again. So we have the circumference, the distance around the tire. This distance right here is going to be equal to 2 times pi times the radius, which is 13. So we multiply that out. We're going to use 3.14 for our estimate for pi. And that's going to give us 81.64 inches. So it does that 10 times per second. So let's get our answer. How fast is it traveling? Let's put in miles per hour. So we need to get per hour here, and we have per second. This time, I'm going to use just dimensional analysis to get that value. So I'm going to go like this. I'm going to say 81.64 inches for our rotation. Okay. So that's the length. Actually, I should write it like this for you. It'll be easier to understand. So we've got 81.64 inches in one rotation. Okay. But we're rotating 10 times per second. That means we cover a distance of 816.40 inches in 1 second. See, because since we're doing that 10 times, just multiply it by 10. So, dimensional analysis, we've got 816.4 inches are covered every 1 second. So we want to get this into miles per hour. So we need miles on top. So let's go ahead and do that. So here I want to put inches on the bottom so they cancel. And I know that there are 12. Okay, so I've got inches on the bottom, so I know there are 12 inches in 1 foot. Okay, so what that's going to do is get our inches to cancel out. So that means that we cover, if we take 816.4 and we divide that by 12, we'll get 68.03 repeating. So 68.03 repeating. Now we're at feet because these inches cancel out, and we've only got feet left there. So we're in feet per second. So our tire is going to travel 68 feet every second. Now we're going to multiply that by something with feet on the bottom. Okay, and we know there are 5,280 feet in every 1 mile. So we'll go ahead and do the division there. So 68.03 repeating divided by 5,280 is going to give us a small decimal value. Don't worry, it'll get bigger in a minute. So this is 0.012885101. So that's miles. I don't know if you can see that because it's on the edge of the screen per 1 second. Rewrite it over here. So let's round it a little bit. We don't want to round it too much because we're going to end up losing accuracy. But I'll go out to this. So miles. So obviously it's not that many miles per second, but we want per hour. The reason I'm converting into per hour is because everyone understands how fast, let's say, 20 miles per hour is, or 40 or 60. You have something to relate that to. Okay, if I say meters per second, that doesn't mean anything to us. Okay, we don't have anything to compare that to. So that's why I'm using miles per hour. So seconds, I'll put seconds on top. So there are 60 seconds in 1 minute. Okay, now the seconds cancel out, and I'm going to multiply that number by 60. So I'm going to have 0.77312, or excuse me, 311. If I round, again, where you're rounding to, the further out you go, the more accurate this is going to be. But this is close enough. So this is miles per 1 minute. Now we want per hour. So we'll put minutes on the top, and there are 60 minutes in 1 hour. So our minutes are going to cancel out, and we're just going to multiply that number by 60, and we're going to get 46 point, I'll say 4 miles per 1 hour. So our bicycle is traveling at about 46 miles per hour. Those are the two types of questions I can ask you. I can say, how fast is something traveling based on how fast it's spinning, or how fast does it spin based on its linear velocity, how far it's how fast it's traveling.